Please make sure you have the HD video toggled on and that you're using the large player window. In this video, we're going to look at some examples of linear regression in action. And we're going to show you how to do linear regression on the calculator efficiently and quickly. And we're going to show you the types of questions that we're expecting you to be able to answer when it comes to using linear regression. So we're going to be using the problem you can see on the screen in front of you right here. This is our first example. Hopefully it looks familiar. It's the same data set that we used in the last video. And so if you have this data keyed into your calculator, you're good to go. If you don't, I would invite you to pause the video and rekey the data so that you have it in there. I already have it keyed into my calculator, as you can see. And I'm using list 1 for the FICO scores and list 2 for the interest rates. And so going back to the book, let's see what we're being asked to do in this question number 18 here. Part A is asking, find the least squares regression line treating the FICO score X as the explanatory variable and the interest rate Y as the response variable. So we're being asked to get the regression equation, and so to do that on the calculator you need to have the data keyed in, as we have. And so I will quit this here and I will go back to the stat menu and I'm going to go to the calc submenu, and hopefully this looks familiar because this is exactly the same procedure we used in the last video to get the correlation coefficient. So we're using number 4 here, which is linreg. It's short for linear regression, and to select it you just press 4. This function defaults to list 1 and list 2. We can certainly tell it the names of the lists if you want, and then you would run your regression. So you can see that the slope of the regression equation is right here, and the y-intercept of the regression equation is right here, 61.368, and so on. Now, most of the questions that we're going to be asking you are going to require you to have the regression equation, or let me back up for a second. The slick response to the questions that we're going to be asking you is going to require you to have the regression equation saved appropriately in the calculator, and we would like you to be able to plot it superposed over the scatter diagram of the data. And if you can do that, it will make these questions much easier to field. I mean, you can do them by hand if you insist, but it's much more time consuming and you can do them much more quickly and accurately on the calculator. So now that I have this result right here, what I want to do is save it. And I want to save it so that I can plot it, and I want to do that without retyping. And so to pull that off, I go to the y equals. This is the memory registers that are used for things which are graphed. And I want to stash my regression equation in y sub 1. So to pull that off, you go to the vars menu. You go to number 5, which is statistics. You use the right arrow key to motor over to the equation submenu. And you'll notice number 1 up here, which is highlighted, is regeq, short for regression equation. That's the name of the memory register that stores the most recent regression equation that the calculator has run. And that's the one we want. So you press enter to take it, and you press enter again to affirm or to lock it in there. And so you can see that the regression equation has now been saved in y sub 1 to its full precision. Let's see what we're being asked to do next. Part B is asking that we would interpret the slope and the y-intercept. Now, this is one of the questions, or actually 2 of the questions that we're going to be asking you. I'm entirely open about this. These questions are basically the same kind of questions you would see in intermediate algebra, and so it's not really new from the perspective of this class. I mean, it's kind of a rehash of intermediate algebra, but anyway, these are the 5 questions. And so one of them is the slope. We will ask you about the intercepts, if it's possible. And we'll ask you about inputting and outputting some values from the regression equation. Now, to answer these the intelligent way, that is using the calculator, you pretty much have to be able to see everything that you need on the screen, and that's why we're always so careful about the window size when we're doing this kind of a thing. Another thing we'd like you to know is that as far as interpreting the slope, it's a lot easier to do that if you are aware of the units of measure that are attached to the slope. And so to put them in intermediate algebra terms, the units of measure are always y units divided by x units, or if you prefer, y units divided by 1x unit. In other words, you can give it as a unit rate. To put it in statistics class terms, we would say, well, the units of measure are response variable units divided by explanatory variable units. All three of those is saying the same thing, effectively. And so to go back to the calculator here, you can see the slope on display right there on the screen, and they're asking us to interpret that. Now, as a decimal, it's a bit unwieldy. I think you'd find it's a little bit easier to write it as a ratio. And you know, we're not going to use it to its full precision to interpret that. I think we'd probably go with something close to it. So, for example, if I were to truncate this slope to 4 places, and that's a good choice. This is a small number, so you definitely don't want to go to, say, 1 place or 2 places. But if you were to go to 4 places, you would write this as minus 0.0764. And you could write that as a fraction of 10,000. Let's get out of this window right here. So, for example, you could write that slope as minus 764 divided by 10,000, if we report it to 4 places like that. You could also write the same slope as negative 7.64 divided by 1,000, or excuse me, divided by 100 in that case, because we basically yeah. Anyway, there you go. And of the two, I think the second one is probably the easiest to articulate. So if you remember, the numerator units, the response variable units, are interest rate percentage points. And the denominator units, or the explanatory variable units, would be FICO score points. And so if we're using this particular ratio right here, negative 7.64 over 100, basically what we're saying is that for every 100-point increase in your FICO score, the interest rate you're going to be charged is going to decline or decrease by roughly 7.64 percentage points. So again, there's your denominator, that's FICO score points, and that would be an increase going from left to right, and the numerator is negative, which means that would be a decrease, and your slope, as they are asking here in part B, interpret the slope and the y-intercept. So the interpretation of the slope is that for every 100-point increase in your FICO score, the interest rate you're going to be charged is going to decrease by 7.64% on the average. Now, as far as the y-intercept is concerned, let's go back to the calculator and see that. Probably easier to go to, let's just run the regression again so we can see it. So I'll go to the stat menu and I'll just use regression. It's easier than going to the y sub 1 register and pulling it up. So there's your y-intercept right there. It's 61.368. And the thing to keep in mind, rather, when you're being asked to interpret a y-intercept, is that the coordinates, if you were to write that as an ordered pair, when you're on the y-axis, the x-coordinate is 0. And so if you can interpret the 0 in this context, then it's very easy to interpret the y-intercept. And so in this case, the y-intercept would be 0, 61.368. And going back to the book, it says, if appropriate. Now in this case, you know, FICO scores only go from 300 to 850. And the FICO score is the x value. And so in other words, it is not possible to have a FICO score of 0. And so in this case, it is not appropriate to interpret the y-intercept because it's nonsensical. It just is a constant which is required by the model in order to make things work. So you really can't interpret it in the context of the problem. Now, part C is saying, predict the interest rate a person would pay if her FICO scores were the median score of 723. Now, of the 5 questions that we're asking, this is number 4. Given X, find Y. And it's important to understand that when that question is asked, it will never be asked you know, directly like that. It will always be asked in the context of the problem, just as it was here. Again, it was predict the interest rate a person would pay if her FICO score were the median score of 723. And so when you read that, what we're expecting you to do is say, interest rate, that's a Y value. FICO score, that's an X value. Hey, you know what? They're giving me an X value. They want me to find the corresponding Y value. So the way we would do that is we go back to the calculator, and we actually need to have the stat plot turned on with the scatter plot. We want to be able to see everything in one screen. So I'm going to take care of that. So if you recall, you need to get the plot turned on, and then you need to make sure you're directing it to the correct lists. In this case, it would be list 1 and list 2. And if you zoom stat that, let's quit that first. There is the graph with the regression equation graphed along with the scatter diagram. Yeah, you probably want to clean the window up just a little bit. So I again would probably go from, say, 500 to 800. And I would make the scale, let's go with 50, that's fine. And then for the Y minimum, yeah, I just go from 0 to 25. And I'll make the scale 5. Don't ever change X res. You get into trouble if you do that. Just graph it. So there's the cleaned up graph. And what they're asking us to do is to input an X value and to find the corresponding Y value. The slickest way to do this is to go second trace. And the first menu function that we have there, value, is the one that you use when you want to input an X value and get the corresponding Y value. So I'll press enter to select it. And it's asking me, well, what X value? Well, they were asking a FICO score of 723. So we'll put in 723. And you can see that the calculator spits out the Y value right here. It's going to give us an interest rate of about 6.154%. And so to answer this question, we would say, well, we're expecting about 6.154%. Part D is asking, suppose Bob has a score of 680 and he's offered an interest rate of 8.3%. Is that a good rate? What they're really asking is 8.3% above or below average according to the regression model? So in other words, what they're saying is, okay, let's go over to the calculator again, and let's use the very same function that we just used. I can't remember the score. They were asking a score of 680. Okay, so an 8.3%. So I'll go back to the second trace, and I will input 680. And according to the model, this FICO score of 680 should correspond to an interest rate of about 9.43%. And the rate that they were offering this guy was 8.3%. So that rate that they were offering him was an excellent offer. It's below the regression model. So if you were to graph that point, 680, 8.3, you'd find it's below the regression line. And so therefore it is a good offer, because the regression model says that the guy should be getting a rate of 9 and some change. Now the one question that's not asked here that we want to definitely flag would be the other example question here, number 5, given Y, find X. So in this particular example, Y values are interest rates and X values are FICO scores. And so if they wanted to ask this type of a question, they would say something like, hey, if somebody is offered a rate of 10.5%, what is their FICO score according to the model? And so when you read that, what we're expecting you to think is, hey, 10.5%, that's an interest rate, that's a Y value. They want me to put in the Y value and find the corresponding X value. And so the slickest way to do this would be as follows. You go back to the Y equals memory register, and we're going to use a second Y sub 2 value here for that interest rate. So we'll put in 10.5. And when we graph that, we find that that's a horizontal line. And so what we're really being asked to find is the X coordinate of the intersection of the horizontal line and the regression model. And the easiest way to do that would be as follows. You'd go to this second trace menu again, the calc menu, and you can use number 5 here, intersect. And it's going to ask you, well, what do you want to use for the first curve? Well, you can see up here at the top of the screen that it's giving you the regression model. So all you have to do is press enter to affirm that choice. And then it's asking you, what do you want to use for the second curve? Well, you can see up here it's giving you that horizontal line. So you press enter to affirm that. And then the calculator is asking for a guess, which is basically, it's saying, hey, could you get me in the neighborhood of that intersection? So you can use the arrow keys to do that. You really don't have to get that close. But in the case where there's multiple intersections, that you really have to do, you have to do it a little bit more carefully. Anyway, you press enter to tell it when you're ready. and then you'll see that the calculator will cough up a FICO score down here on the bottom. X is 666.09 and some change. And so that is the slickest way to answer that type of a question, and we'll show you some examples of that in action. I hope you found that this video is helpful. Please click on the link and take a look at the next one that we have.